Most organizations think their wireless network is secure, but attackers can bypass those authentication methods in a minute. Username with password, it's suspectable for the credential theft. Evil twin attacks. In Windows 11, Credential Guard is now by default enabled in the Enterprise Edition. So Microsoft is depreciating this username and password based authentication. EAP-TLS solve this problem, but it only authenticate one identity per connection, either user or either machine, not the both. In this video, I am going to show you the EAP-TEAP Tunnel Extensible Authentication Protocol. This is one of the most secure wireless authentication protocol available. It combines machine and user both in a single encrypted TLS tunnel, and now it is natively supported on Windows 11 and Windows 10 PCs. So why we will not implement that one? In today's video, we are going to cover the protocol, real world use cases, the full ClearPass configuration based on the Aruba official document, and also we are going to verify the authentication by using the access tracker logs. What is TEAP? TEAP is Tunnel Extensible Authentication Protocol. Is defined in RFC 7170. It has been natively supported on Windows 10 and Windows 11 since the Windows 10 build 2004 release in May 2020. The key thing to understand about EAP-TEAP is its layer structure. Let me show that one into you. At the bottom, you have carrier protocol, which it is radius between network devices and ClearPass, or EAP over LAN between supplicant and the access point. Above that, EAP layer, then EAP-TEAP itself. EAP-TEAP first establish a TLS tunnel, and it is a critical. TEAP doesn't support TLS version 1.0, 1.1, only supporting 1.2 and above. Inside the TLS tunnel, you have TLV encapsulation, aka type, length, value, contains. And this is where inner EAP methods run. Important point to remember, tape authentication have two phases. Phase 1 establish the protected TLS tunnel, the anonymous user identity, tape version, EAP method, type. These type of things are exchanged in the phase 1. Outside the tunnel, which it is phase 2 happen entirely inside the TLS tunnel. Security best practice from official Aruba guide, always use a generic anonymous identity in the phase 1. So real usernames are not exposed in the radius message in clear text. Now let me draw the actual authentication flow. This is what happened on the wire when Windows PC connected to your enterprise SSID using the EAP-TEAP protocol. Step 1 is the client send EAP identity response. This goes from AP or controller, which wraps in radius access request, and it will forward towards the ClearPass. In step 2, ClearPass negotiate the TLS tunnel setup. This is the phase 1 which I mentioned in that important points. The anonymous identity, type version, EAP method, these things will be agreed in here. Now we enter the phase 2. Everything from here happened inside the encrypted TLS tunnel. This is where authentication chaining is happening. In step 3, method 1. This is machine authentication. The client send computer certificate, ClearPass validate it against the Active Directory using the radius challenge and request exchange. When the machine certificate is valid, ClearPass send back an intermediate TLV success. It's not the fully access accepted, just an intermediate success to that signal to the ClearPass that method 1 is pass. It's happening in here. In step 4, this is the actual method 2, it will happen. In here, it will validate the user authentication. The client now send the user certificate inside the same TLS tunnel. ClearPass validate this against the Active Directory. 5. ClearPass evaluate both method result. Applies enforcement policy and send the radius access accept back to the AP. Client receives EAP success and connected. The key point in here, ClearPass expose both result as a computed attributes. Authentication TEAP method 1 status and authentication TEAP method 2 status. You can make the policy your enforcement policy by using these attributes. Alright, let's jump into the ClearPass, start building the full EAP-TEAP policy. In here I want to be very specific because there are some few specific things which it is very easy to miss. So let's start the configuration. I forget to tell you, TEAP is not included in the ClearPass as a default authentication method. You must create it manually. This is the most common mistake people are doing when they are going to configure the EAP-TEAP in the ClearPass, because they cannot find it in the service and select trying to find the TEAP in the authentication method, but they cannot find it because it's not default in the ClearPass. You have to manually create it. Let's start now. Let's go to the ClearPass policy manager. You can log in. First thing is we need to create an authentication method. As I mentioned, it is very critical because EAP-TEAP is not available in the by default in the authentication method. So I will use the name as a TEAP. I will give a description. I will select the type as TEAP, and in here I will select the method 2 and I will keep the session cache and session timeout is 6. In a method I will select the EAP-TLS. In mind, you can go with the MS-TAP also, but as I mentioned, like MS-TAP is now depreciated from the Windows. They are enabling this credential guard, and nowadays it's not, Microsoft is not recommending to go with the MS-TAP authentication method. So we'll stick into the EAP-TLS and we will click save. So our TEAP method is fine. Now we need to create a custom filter attribute in the AD to fetch the authentication paces. Like I mentioned earlier, like we need to fetch the attributes to the ClearPass. So we'll do that one now. We'll go to the authentication sources, we'll go to the AD attribute, we'll click add more filter. From here we will click on the configuration, give a meaningful name. I will give machine details, and in the query I will paste this query. We will click on save and we will save again. So now the authentication source modification is complete. So we will coming to the service and then we will click on the staff wireless authentication service. In here we need to add the TEAP from the authentication method. So I already add it, so you can see we have to select it from this list and then we have to add it, and then we have to save. And let's try the authentication first without doing any modification to the roles and enforcement policies. ClearPass configuration is completed now. Let's see what are the settings that we need to change in our PC level to authenticate the client by using the EAP-TEAP. Let's go into the PC level configuration now. Okay, let's see what are the settings that we need to configure in the client PC. Easily you can go to the control panel. You can select the network and sharing center. In the Wi-Fi profile you can select Wi-Fi properties, click on security and select EAP-TEAP as the authentication method and click on the advanced settings and select the user or compute authentication and enable this one. Click OK. Then come into the settings. In here, this is what I mentioned in the earlier. It's important to remember that enabling the anonymous as the identity, so your name will not be exposed in the radius. So you can keep this one as the anonymous as a best practice, also as a hardening of your authentication. And in here you can select the method, client method, and the second method, primary method and the second method. Primary method you can select smart card or the certificate, and also the second method also you can select the smart card or certificate. You can see in the both methods there is EAP-TEAP method also available, but this is not recommended by the industry or in the Microsoft, because they are going to depreciate this method. So keep stuck into the smart card or certificate and click OK. So click OK again. You can see your client is connected to the SSID. You can click and connect. It will ask to connect. You can click on connect. So your PC is now connected to the okay. Client side is showing now authentication is successful and it's connecting to the SSID. Let's go to the access tracker and verify the authentication status. Okay, now in the access tracker we can see our authentication request is reached, and here you can see machine and user both is authenticated in the roles. Let's go into the input tab and go to the compute attributes. You can see it is EAP-TLS inner method, yes, and authentication is status user and machine, and method 1 it is TLS, method 1 is success, and method 1 username it's a computer name, and method 2 also EAP-TLS, status is success, and username is Andy, and we can see TLS version 1.2 and the username. So we can see all of these details in the single access tracker request. But you can see in down there is a request came without an username, and also you can see it is only one EAP-TLS and the other one is not showing. What is the reason for this one? If you check this one carefully, you can see it's only the machine is authenticated and user is not authenticated. That's why it is showing only the machine name in here. But why it is not showing the machine name? We will fix this one. Okay, to fix that issue, let's create two roles in the clear pass, and one is we will mention as tip user, and the other one we will mention as tip machine. It's done. Let's go to our role mapping and we'll click on user role mapping roles. In here we have to select all matches, because we need to map multiple roles into a single request. So we'll select all, we'll add the rule, and we will select authentication outer method equals EAP-TEAP authentication TEAP method 1 status equal success. We will mention this one as a because TEAP method 1 is always for the machine users, so we will select TEAP machine and we will click OK. And we will do the same for the user also. We will copy this one copy rule, we will edit this. Outer method is fine, and we will select this one as method 2 status equal success, and we will select TEAP user and we will click on save. Now role mapping is completed. We will do a enforcement profile also for this one. We'll come to the enforcement, we'll create a profile, click on add. We can select radius based enforcement, TEAP, machine name update. We'll come to the attribute EAP-TEAP username. Here, before doing this one, before grabbing this detail, I will make a duplicate session of this request. I will come to monitoring access tracker. I will select the success message. I will come to input, click on the computed attributes. I just want to copy this username method in the access tracker. Otherwise we have to type this one manually, but it is easy, we can copy that one from the here. Okay, we copy the attribute. We'll come into the our enforcement profile. We'll select the percentage mark. You can see the curly brackets, and we will paste this one, and we will close the bracket, and we will save it. That's it for the method 1. Click save. We'll filter that one. We'll take a copy of this. Okay, we took a copy of this one. We will modify this profile. This will be username update. Username update, will come to the attribute. So we will copy this attribute from here. It is username. Sorry. Click on this one, and we will paste this one in here, and we will click on save. So our both methods are configured now with the enforcement profiles. So we will bind these enforcement profiles into the enforcement policy. Let's modify our enforcement policy based on our requirement. So we'll come to the enforcement policy. We'll select the finance role because that is the user right now we are connecting. It's in the finance department, so we will modify that one now. So it's finance role, and we will select tips role equals TEAP user, and then we will send TEAP username update, and we will click on save. That is done. Now we need to create a policy for the machine authenticated also. So we'll click add rule. We'll select tips role equals TEAP machine, and they will select machine update, and we will select allow all access. Click save. Click save. Okay, let's authenticate the user one more time, and then let's see how the behavior. Okay, now user is authenticated. You can see in the access tracker machine detail also coming as the username, and look in here, it is showing only one. So machine authentication and user authentication both success. You can see TEAP user and TEAP machine both is authenticated, and it is in the finance role, and also it is enforce update the username enforcement profile which we created, and the finance user role. If we come to the compute attributes, you can see user and machine both is authenticated, it is TLS, all those information which we checked earlier, it is available in here. We will jump into the control also. So you can see our client is successfully connected. And that is the complete of the TEAP configuration. RFC to whiteboard to authentication verification by using the access tracker. Let me quickly summarize what we learned in this chapter. So in here we learned about EAP-TEAP, establish a TLS tunnel that runs two inner methods, one for machine and one for user. Both of these methods are combining and make the EAP chaining. Method 1 is using for the machine authentication and method 2 is using for the user authentication. Also we learned TEAP is not enabled by default in the ClearPass. You have to manually configure that one in the ClearPass. If you are deploying a new wireless solution today, it's recommended to go with EAP-TEAP because Microsoft is already depreciated the EAP-PEAP, otherwise password, username and password based authentication method. So all the Windows PCs are right now it's supporting the EAP-TEAP method, but unfortunately Mac OS and the Linux still it's not supporting the EAP-TEAP method. So if you have a Windows environment, you can deploy this method without any hesitation because it's supporting now in the Windows 10 and Windows 11 PCs. In the next video, we are going to authenticate wired users by using the certificate. Make sure you subscribe to the channel so you will not miss the video. If you missed my previous video, which it is TLS based authentication for the wireless users, you can watch that video from here. I will see you in the next video. Thank you for watching.